Hi everyone, this is Mr. Murray and I'm going to give you a video on the introduction to probability. So just some basic concepts that I hope you've already learned or recognize from your Algebra 1 course. So let's start by defining what is probability. It is the percentage, or it's the decimal value that you get from a fraction, and the fraction is the number of desired outcomes divided by the number of possible outcomes. And if you want to be really fancy about it, it's the number of items in the event space divided by the number of items in the sample space. So when you figure out this fraction, you should always have a decimal, and it better be between 0 and 1. And it could equal 0 for sure, and it could equal 1 for sure, but it can't be anything bigger, and it certainly can't be negative. How many times have you heard someone say, I'm 110% sure, blah, 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 blah? That's just not right. It's impossible. That would be like saying you have a decimal of 1.1. That doesn't happen in probability. So make sure you have a decimal, which we've had in statistics, right, when we were doing area under the curve. And make sure that it's a positive decimal and it's somewhere between 0 and 1, all inclusive. So let's just take a quick example, like what do you mean by desired outcomes and the number of possible outcomes? Well, if you wanted to know the probability of picking a jack from a deck of cards, we can go to our definition. So the probability of jack will be desired outcomes, which is a jack, right? Well, there's 4 of them in a deck of cards. And there are 52 total cards in a deck. Well, it's that simple. The probability is literally 4 over 52. So let's make it look nice. We'll make it into a decimal and perhaps round to like the 10,000th. So 4, I'm just on my calculator right now. 4 divided by 52, 0.0769. Okay. So there's about a 7.6% chance that you would pull a jack. And that might put the game of blackjack in perspective for you and realize why Atlantic City always makes all the money. Okay, so anyway, that's the definition of probability. What are you looking for out of what's the total possible things that could happen to you? That's probability. Okay, so let's move on. Oops, too soon. Okay, so it's all about the sample space, about, what are the total possible outcomes. So what we'll talk about right now is this thing called counting principle and how it differs from the tree diagram, but they give you the same information. So let's talk about this man, Mr. Giggles, and he's buying a Nissan Altima, and he's got to figure out 3 things. Does he want a 2-door, 4-door? There's 5 color choices, and there's 3 trim levels. Most cars come with EX, which means, I don't know, exciting, LE, which is luxurious, and SL, which is a combination of sporty and luxurious at the same time. All right, well, how many possible cars are there for him to choose from? Well, here's the counting principle and how it can help us. It basically says if there are m ways to do one thing and n ways to do the other, well, if you simply multiply them together, m times n, that's the total amount of ways that you can do both. And the really important thing is it's not limited to 2. So in this Mr. Giggles example, he's got 3 things going on. We could use the counting principle for that. It's limitless. You can use it for as many things as you'd like. So let's try to figure out how many cars he can choose from. All right, well, he has to choose, first of all, 2-door, 4-door. So that's 2 choices. Then he has to choose from 5 colors. So that's 5 choices, or 5 ways of picking a color. And now the trim level. There's 3 ways for him to choose a trim level. The counting principle basically says if you multiply these 3 numbers together, you'll have the total amount of ways that you can pick a car. So 2 times 5 is 10, times 3 is 30. Cool. Now on the next slide, I'm going to show you the same situation, but using a tree diagram to find that there are 30 types of cars that can be picked from. The sample space is 30. And I drew it ahead of time just to save time and to be neat about it. If you can call this neat, right? But this is what a tree diagram looks like. You start out with your car. You want to purchase a car. And your first two choices, order doesn't matter. You can do whichever one you want first. You could pick color first if you'd like. That's fine. I did it in a way that the tree would look beautiful. So the first choice I went with was, what type of car do you want? 2-door or 4-door? So you make this little tree branch here to the 2-door and the 4-door. Now, once Giggles has figured out he wants a 2-door, wouldn't you agree that he can now choose from 3 different trim levels? So we drew out these trim levels over here. You've got the SL, the LE, or the EX. And once he's picked a trim level, there are 5 colors he can choose from. So we repeat this for the 4-door version as well. And you'll notice that there are 30 at the very leaf level of this tree. This is called the leaf level. There are 30 items. And if you look at this item right here, what does it stand for? This item, the BL, stands for a black SL 2-door car. This S stands for a silver SL 2-door car. And you can see that by counting these numbers, you get 30 total possible cars. Now the question in this example is saying, okay, let's say, like, I don't know, he won some kind of game show thing and they blindfolded him and sent him out into this Smithtown Nissan dealer into a parking lot of all of his cars, these 30 cars. And they said, the first one you bump into is yours. What's the probability that he's going to bump into a red EX? Well, by looking at a tree diagram, it's actually pretty easy to see the probability. Let's look for red, and let's look for an EX. Okay, well, here's my EX, and here's another EX. Now, where's red? Right here, and right here. So my sample space for this question is 2. I'm sorry, the desired outcomes is 2. There are 2 red EXs in this parking lot. The sample space is 30. It's that simple. 2 out of 30. Let's turn that into a decimal. And we get 0.066666. 0.066666. So 06 with the line over the top. That's the probability, or somewhere around a 6% chance that he'll get a red EX. So that's a tree diagram. It's another way to calculate sample space. And the page before that was the counting principle, another way to calculate sample space. Now, counting principle works great for any question, and I think tree diagram really only works maybe if it's about this big, because you can imagine if the numbers get large, you would need a very big piece of paper and a lot of patience and a lot of time to draw this all out. Okay, so let's try some empirical probability versus theoretical probability. 2 important vocabulary words for you to know. So empirical probability is sort of like what we did in statistics. We analyzed data, we sent out surveys, and we found population proportions and sample proportions and stuff like that. That was actually by doing. Theoretical probability is stuff that you just know. For example, flipping a coin. What's the probability you'll get a head? Well, you know it's a half because it's either heads or tails. That's very theoretical. Whereas this question here talks about empirical probability. You went into a cafeteria and you surveyed 85 students and said, what's your favorite breed of dog? And now we want to know what's the probability that the favorite breed of dog would be Labrador? Well, let's take a look. The desired outcome is Labrador, which is 35, based on your survey. The sample space is, 85. So the probability of Labrador is simply this fraction, 35 over 85. And if I turn that into a decimal in my calculator, 0.4117, I'm going to round it up to 4118. That would be to the nearest 10,000th. Or about 41% is the probability that a student's favorite breed of dog is Labrador. Now, in the theoretical world, we know the probabilities. They're like textbook. So what's the probability of rolling a 4 on a fair die? Well, there's only one way to roll a 4. And the total, or your sample space, is 6. Because there are 6 numbers on a die, 6 faces, and there's only one of them that's a 4. And if we turn that into a decimal, we get 0.166666. So I'll just put a line over the top. That's the probability that when you roll a die, you'll get a 4. It's 1 out of 6. Pretty intuitive, wouldn't you agree? This second example is great for counting principles, horrible for tree diagrams, because you in your closet have 8 shirts, 3 pants, 12 shoes, and 4 belts. How many outfits can you possibly make from that? What's the sample space? Well, that's going to be pretty massive. So the sample space is the counting principle. So you've got 8 times 3 times 12 times 4. And you'll be surprised it's a little large. Let's see. 8 times 3 times 12 times 4. There are 1,152 possible outfits that you can make, as long as you don't care about matching, from 8 shirts, 3 pants, 12 shoes, and 4 belts without repeating. These are the unique possibilities. Pretty cool. So now you can imagine that a tree diagram for the 8 shirts and each shirt having 3 pants would just become unruly, because at the end there would be 1,152 leaves at the very end of your tree. So in cases like this, it's much more efficient to just use the counting principle. The third example talks about license plates. So license plates, as you know, usually have 3 letters. And in the middle there's like I love New York, or let's see, Statue of Liberté, right? And then there will be 4 numbers. So assuming that you can repeat numbers and you can repeat letters and there's no restrictions, how many ways can you put the first letter in the first position? Well, there's 26 letters in the alphabet. And then for the second letter, there's 26 letters. And for the third, there's 26. Now let's work with the numbers. In this first position, you can choose from 0 to 9. That would be 10 numbers. And the same for there, same for there, same for there. This is going to blow your mind. For New York State, which usually makes their license plate in this format, the total number of license plates, the sample space, if we were working with probabilities, would be the counting principle. 26, 26, and then 10, 10, 10, 10. And it's an outrageous number. I'm just looking at my calculator right now. 175 million license plates can be the sample space. 760,000. That's the total number of plates that you can have. So using the counting principle to calculate the sample space really made quick work. There's not a chance in the world that you can make a tree diagram out of this one. All right, and our last example, if you had a deck of cards, well, what's the probability that you would pull a red ace? So your desired is a red ace, and your total would be 52. So how many red aces are there? 2. So very simply, 2 divided by 52, that would be your probability. 0.0384, I'm going to round it up to 0.0385. That's the probability of pulling a red ace. Okay, so that was a brief introduction to probability, and I hope you enjoyed the video and that it made sense. And we'll see you tomorrow. I hope you have a great night. Take care.